Hey there, this is Randy. Today we will learn to complete polynomial identities through manipulating expressions, whether by multiplication or by factorization. Let's go. So they give us x squared plus 8x plus 9 equals something. And they want to know which of the following expressions correctly completes the identity. And here we have our options. So first of all, what is an identity? Well, an identity is a true equation. So in order for this right here to become an identity, we need some expression on the right that will make this equation true for all values of x. So how could we figure out which option is the answer? Some of you are probably thinking, hey, we could factor this right here, and then maybe it would give us one of these options, right? Well, good thinking, but we actually cannot factor this expression. So what could we do instead? What we could do is actually start testing these options. And so we can do some multiplication here in these expressions in order to hopefully get to an expression that is the exact same as this. Okay, so let's start with A. What could we do to rewrite this? Well, x plus 2 squared is the same as saying x plus 2 times x plus 2. Then we still have plus 2x. So plus 2x. So let's multiply this out. X times x is x squared. And then x times 2 is 2x. So plus 2x. And then 2 times x is 2x. So again, plus 2x. And then 2 times 2 is 4, plus 4. We still have plus 2x from up above. So now we can combine 2x, 2x, and 2x. That is going to give us 6x. So let's rewrite this again, and we're going to have x squared plus 6x plus 4, just like that. Now we cannot simplify this anymore. So the question is, do we have the exact same expression as we had originally? No, we don't. We do not. So that means that A cannot be the answer because it does not give us an identity. Now let's test option B. So x plus 3 squared plus 2x is what we're going to try to rewrite. So we could write this as the following. We could say x plus 3 times x plus 3 plus 2x plus 2x. So let's multiply these out. So x times x will give us x squared. X times 3 is 3x, so plus 3x. And then 3 times x is 3x. So once again, plus 3x. And then lastly, 3 times 3 is 9. So plus 9. We still have plus 2x. Okay, now let's combine like terms. We have an x term, an x term, and an x term. So 3 plus 3 is 6, plus 2 is 8. This is looking good. So let's write this expression now with those x terms combined. So we have x squared plus 8x plus 9. And now we cannot simplify this anymore or multiply anything else. So is x squared plus 8x plus 9 the same as what we had originally? Yes, it is. So if we were to write this expression on the right, we would have the exact same expression on the left and right, which means that B is the answer. If you were to test out option C, you would see that it would not give us an identity. And because we know B is the answer, we know that D will not be the answer. So that is everything for that first example. Now this example probably looks harder than the first one, but I would actually argue that it's easier because we can actually factor this expression. So let's factor this, and hopefully it will give us one of those options. So what is the greatest common factor among this term, and this term? Definitely 2 something, right? Because each of these are divisible by 2. And we also have an x squared in common. So let's factor out a 2x squared. Now when we factor out that 2x squared, we are dividing this term, and this term by 2x squared. So let's do that division. So 2x to the 4th divided by 2x squared will give us x squared. 12x to the 3 divided by 2x squared. Let's not forget this plus here. Well, 12 divided by 2 is 6. And x cubed divided by x squared is x. Now 16x squared divided by 2x squared is going to give us, let's see, 16 divided by 2 is 8. And x squared divided by x squared is 1. So 8 times 1 is 8. Okay, now we can still do some more factoring, because if we take x squared plus 6x plus 8, that can actually be factored into two binomials. So this trinomial right here is actually a sum product pattern, because there are two numbers whose sum is 6 and whose product is 8. What two numbers are those? It's 4 and 2. So watch this. Our binomials will start with x, 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 and this time they're both positive. That is the numbers in the second part of each binomial. And like we said, 4 plus 2 is 6, so 4 and 2, and 4 times 2 is 8. Now if you were to multiply these binomials again, you would see that you do in fact get this trinomial. Now let's see if what we have right here is the same as any of these options. Looks like they all are pretty similar to what we have, but this right here has x plus 3, but this has x plus 4, so the answer is not going to be A. Let's see, B has 2x squared, x plus 3, x plus 4, but we need this to be x plus 2, so not B. Let's see if option C is the answer. 2x squared, good, x plus 4, good, and x plus 2, good. So C is the answer, which means that D will not be the answer. So if we take this expression and we put it over here on the right, then we know that the left and the right are exactly the same, which means that we have an identity. And with that, we are finished. See you next time.